All right, so today we are going over lesson 1.2, measuring and constructing segments. Okay, again, we are still in chapter 1, and let's get started. All right, so the warm-up was given in class. It basically went over when two planes are intersecting. It was labeling some information about that. So just be sure to be familiar with questions where it asks you about two planes intersecting. All right, so the first thing that we are going to learn in this lesson is the ruler postulate. Now, the ruler postulate is a fancy name for just saying that if we know 2 points, for example, A and B, we're going to give them coordinates x1 and x2. And what we can basically do is we can find the distance between A and B by subtracting x2 by x1, okay? So if we look further down here, we have that AB is equal to the absolute value of x2 minus x1, and that will give us the distance between A and B, okay? It's a fancy way of saying just basically look at it as a ruler, okay? So next, the ruler postulate with an actual ruler, okay? So what the ruler postulate says, S is located at 2, so our x1 is going to be 2. T is located at 5.4, so our x2 is going to be 5.4, okay? Now, what we do from here is we say that it's going to be called ST, which is the length between S and T, is going to be equal to the absolute value of 5.4 minus x1, which is 2. All right? Now, from here, we simplify the inside. 5.4 minus 2 is 3.4. The absolute value of 3.4 is just 3.4, okay? So we use the ruler postulate for this one. All right, the next one. I would like you guys to pause the video and try this on your own, okay? Then when you're done, you can check your work with mine. So let's see this one. W is around 1, so x1 equals 1. And x is right around 3.1, so x2 is going to be 3.1, okay? The distance of the line segment wx then becomes the absolute value of x2, which is 3.1, minus x1, which is 1. So some people ask during class, well, Mr. Yurko, could you have done it 1 minus 3.1? You could have, okay? Either way is fine. I always like to subtract the smaller number, x1, from the bigger number, 3.1, but you can do it the reverse. It'll all end up with the same answer because it is simply the difference, and then you're taking the absolute value of it, okay? So 3.1 minus 1 will give us the absolute value of 2.1, which then turns out to be just 2.1, all right? So that is the distance between W and X. Moving on. So we've got one definition that I want to go over, and that is congruence, okay? Congruence is when line segments have the same length, they are called congruent segments. So over in this visual section, I want you to draw your best 2 line segments. We'll label the first A to B, and then draw another one, C to D, and try to make them as close to the same length as you can. All right? Now, to show congruence, all we do as mathematicians is we draw a little line in between the two, or in between the segments. Okay? This means that line AB is the same distance as line CD. If we had 2 strokes through AB and 1 stroke through CD, that would indicate that they are not the same distance. So we will not do that. Okay, so we've got one for AB and one for CD. All right, so what we're going to do next is we're going to say that the length of AB and CD are the same. Once we know that, what we are able to say is that AB as a line segment is congruent with CD as a line segment. Now, that thing that I wrote in the middle is a squiggly on top of an equal sign. This indicates congruence. Okay? That is the universal symbol for congruence. All right? If two lines or line segments are not the same distance, let's say we have another line which is clearly bigger, EF. Since this one's bigger, we're going to put 2 dashes through it. We can say that line segment AB is not congruent with line segment EF. That is how we show that they are not congruent. Okay? All right, let's move on. Are they congruent? So we've got two line segments, JK and LM, over here on our left. I am going to use two different colors so I don't confuse anyone. Let's circle J and K in green. And then let's circle in red L and M. Okay? So let's go ahead and take care of J and K. Now, first off, what I want you to write on the top is horizontal. Since this is a horizontal line, we are going to use the x coordinates. So use x coordinates. Okay? And by doing this, we can find out that JK is equal to, and our x2 in this instance is 2, okay? Because that is where K is located on the x-axis. And then we are going to subtract -3. Why? Because that's where J is, okay? What we get here is 2 minus a -3, which essentially is 2 plus 3, which becomes 5, okay? And for the second one, it is a vertical line. So over on the bottom, we're going to write vertical. Use y coordinates. Okay? Whenever it's a vertical line, we are going to use the y coordinates. That would be the 3 and the -2. Okay? So let's do LM equals. Now, our y2 is the 3 minus -2. Okay? This will turn into 3 plus 2, which is the same as 5. Okay? Now, if you had done -2 minus 3, I'm going to show you guys that you would get the same answer. So it doesn't matter which one you start with. You could have started with M's y-coordinate or L's y-coordinate, but you have to subtract them, okay? So -2 minus 3 becomes the absolute value -5, which is 5, okay? So these two match. Check mark. All right, so we also see that line segment LM is 5 units and line segment JK is also 5 units. What can we conclude? JK as a line segment is congruent with LM as a line segment. Okay? If the distances of the lines are the same, they are congruent. That is the whole definition. Let me jump back really quickly. So one thing I do want you to notice is if you were to simply eyeball the two lines, you would see that the first line is 1, 2, 3, 4, 5 units long. If you were to eyeball the second one, it is 1, 2, 3, 4, 5 units long. Okay? So all this work that we did on the right, you could have just said, oh, they're both 5 units long. They have to be congruent. You won't get any credit for that answer, but it's a good way to double check your work. So if one of these was 4 units long, but you're saying that they're congruent, you would be incorrect. Okay? So it is helpful to use for checking your work. All right, moving on. So what I want you to do is we are going to plot 4 points, and then we are going to determine whether the segments are congruent. Before we do that, all right, so are they congruent? Plot A, which is -2, 4. So we're going to move over 2 spaces in the X direction and then up 4 spaces in the Y direction. We're going to end up here. So this is our point for A. For B, we are going to move 3 units in the X direction and then 4 units up. That would be right here, okay? And since we are looking for the line segment AB, let's go ahead and right now draw our line between them, okay? So that is our line segment AB. All right, next we are going to plot point C. So C is at 0, 2. So we're not moving anywhere in the X direction, and we are just moving up 2 spaces to 2, okay? Let me see if it'll erase this. Nice. Okay. And so we've got that point for C. Let's label that. And then our second point for D is 0 and -2. So it's going to be right here. Okay? Let's go ahead and draw a line segment connecting those two. So those are our 2 segments. Let's go ahead and get started. So the one thing that I want to do is I want to write in the same color as my line segment. So AB is going to be equal to the absolute value. Remember, it is a horizontal line, so we're going to use the X coordinates. We can do 3 minus -2, okay? Which becomes 3 plus 2, which is 5, okay? And let's go ahead and do CD, which is the absolute value. It is a vertical line, so we're going to use the Y coordinates, and it is going to be 2 minus -2, which is absolute value of 4, which is 4. 5 and 4 are not the same length, okay? They are not the same. So what can we conclude? Line segment AB is not congruent with line segment CD. All right? Now, one thing I do want you guys to notice, we could always check our work, okay? So this AB line is 1, 2, 3, 4, 5. And this CD line is 1, 2, 3, 4. So right off the bat, we knew that they are not congruent, but we just proved it with this work that we showed right over here. Okay? Very important stuff. All right, moving on. Okay, the segment addition postulate. Sounds super intimidating. It is one of the easiest postulates you will ever learn. So if B is between A and C, then AB plus BC equals AC. If AB plus BC equals AC, then B is between A and C. So basically 1 plus 1 equals 2. That is all this postulate is saying. If you look at the image on our right, on that line you see 3 points, okay? There we have an A, we have a B, and we have a C. All it's saying is that if B lies in between A and C, we can say that AB plus BC is going to be equal to AC. In other words, this segment right here plus this segment right here will be equivalent to the whole thing right here. That's pretty easy, right? Basically, if we had the number 2, one half of it would be 1 plus the other half, which is another 1, would be equal to 2. Okay? Or in other words, you could say like 1 plus 2 equals 3. If we had a line segment that was 3 units long, you could break it up into one segment that is 1 unit long and another segment that is 2 units long. Okay? All right, that should make perfect sense to everyone. That is called the segment addition and we are going to practice using the segment addition postulate. Okay, so it's asking us in the first one, find DF. That would mean that we are finding the distance between D and F. So the distance of the whole thing. If your initial reaction is to take 23 and just add it to 35, you would be correct. Okay, now I'm going to write the official wording of it, but you are not wrong if that was your initial reaction. So DE plus EF is going to be equal to DF, okay? So that's what we're looking for is DF. And we know that DE is 23, so let's go ahead and plug that in. Plus, and then 35 was the distance between EF. So now we've got DF. So DF is equal to 58. Okay? All right, so now let's look at B. Find GH. So now it gives us the entire length, which it says is 36 from F to H, and it gives us that from F to G is 21. Okay? So I'm going to write down below FG, which is this segment right here, plus the distance between G and H is going to be equal to the total distance from F to H, okay? This whole distance is going to be a combination of this one and this one, which we don't know, okay? So FG is 21, we can go ahead and plug that in, plus GH, which is what we're trying to find, is equal to FH, which is 36, okay? Now all we have is basically a variable, which is GH, the unknown length, and we are solving an equation. What you want to do is you want to subtract 21 from both sides. So now GH is equal to 36 minus 21 is just 15. Okay? Pretty simple, guys. If you were to eyeball this and just say, okay, the whole length is 36, this part is 21, so this has to be 36 minus 21. You are absolutely right, okay? I do want you showing this work, though, because that is what the second addition postulate is. All right, and that was all the notes for this lesson. Go ahead and start on your homework. It's pages 16 and 17, which has been uploaded, and those are the numbers you are doing. If you have any questions, email me as always, and thanks for listening. I will see you guys tomorrow.